Okay, so we've got to find the sum of this geometric series. Well, I'm going to put things together. I'm going to put the 1 plus x cubed. So let's have this 1 plus x cubed plus x to the power 6 plus dot 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 plus x to the power of 3n. And then I'm going to take away the x. And I've got minus x. I've got a bracket there, so that will be a plus x to the power 4. Because that would give me minus x to the power 4, which is what I've got up there. And then plus x to the power 7 plus dot 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 plus x to the power of 3n plus 1. And that's what I've got to do. So start off here. First term equals 1. The common ratio equals, it's gone up, I'm timesing by x cubed. And the number of terms is, well, it's not going to be n, so it goes up in the 3 times table. So we've got here, each of these are in the 3 times table. So 3 times 1, 3 times 2, 3 times 3, 3 times n. So there's n of those, and there's also that one there. So number of terms equals n plus 1. And then over here, we've got the first term equals x. The ratio is still x cubed. And the number of terms, which all just shifted one along, so number of terms is still n plus 1. So I can now work out what we got. So sum of this one here is a, which is 1 times by 1 minus r, which is x cubed, to the power of n, which in this case is number of terms, which is n plus 1, all over 1 minus r, and r is x cubed in this case. I've got to do that, and I've got to take away the sum of this, which is just the same as this, but it's got x, and then 1 minus r, which is still x cubed, to the power of the number of terms, n plus 1, all over 1 minus x cubed. And so this gives me, we can see hopefully quite easily, we've got a common denominator, so it's definitely going to be over 1 minus x cubed. And the top bit, the bracket bit, is the same in both of them. So I've got 2 of those, so I've got one lot of it, and then I'm taking away x lots of it, so I've got 1 minus x lots of that bracket. So 1 minus x cubed to the power of n plus 1. And when you've got power of a power, I times them together. So that'll be 3n plus 3, like so. And that goes, this line goes straight to that. That's what it is. That's what the sum has got. Let's show sum to infinity. Okay, well, for sum to infinity to exist, then this term, the x to the 3n plus 3, must tend to 0 as n tends to infinity, i.e. minus 1 is less than x, which is less than 1. Now in that case, then we've got sum to infinity equals, well, this bit will become 0, and so we've got 1 times that, so it's going to be 1 minus x over 1 minus x cubed. Best thing now to do is to factorise the bottom and see if I get anything like that. So I'm going to factorise the bottom. I'm going to do it this way. I'm actually going to assume that 1 minus x goes into it. So I've got 1 and minus x, and I've got to get, it's going to be a quadratic because I've got to get this x cubed. So that's going to have to be, well, it's actually a minus x cubed, so I need that to be a minus x cubed, and that's going to mean I've got to have an x squared here as part of my quadratic. But x squared times 1 gives me x squared, and in this expression here I've got no x squareds, so I need to make sure I've got an x squared there. I need to have a minus x squared here. To get a minus x squared, that will be minus x times by a plus x, and that will give me my minus x squared, so I'll have no x squareds, but that will give me a plus x, and I've got no x's down here, so I need to have a minus x here, so get rid of the x's, and that means I'll need to have a plus 1 here, but that will give me a 1 there. A plus 1 but it's not, oh dear, that is what I wanted, so I've now worked it out. So sum to infinity equals 1 minus x over 1 minus x times by x squared plus x plus 1. And obviously the 1 minus x's will cancel out. Well, it leaves just 1, dividing top and bottom by 1 minus x. And that says sum to infinity equals over, and instead of writing it this way around, I could write it the other way, 1 plus x squared. So I've done that, and I've stated when it's valid. I've done that. Use a similar method to find the sum of the infinite series. Well, I'll start it in green. What we're going to start with is splitting it up. 1 plus x to the 5 plus x to the 10 plus dot 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 dot, and then minus, that will be x plus x to the 6 plus x to the 11 plus dot dot dot. And then it's going to be a very, very similar process. But that's me done.